Let us discuss a very good problem of rotational dynamics. Similar problem has been asked in JEE Advanced few years back. This is based on a concept that normally we apply a relation torque equal to I alpha to relate torque and angular acceleration, and this relation is applied either about fixed point, pivoted point, or about Cm. But there is situation that when I is not constant, means body is not rigid, the system is having such a configuration where I is changing with time. In that case, this relation cannot be applied, and that is the chance of mistake in the problem which I am going to discuss. People may attempt to apply this relation and that will be wrong. Let us see the problem. Here we have a massless rigid rod and insect here top end is pivoted. Say length is L. A horizontally moving insect strikes perpendicular to the rod, and the rod acquires certain angular velocity omega naught. And insect does not leave the rod; it starts slipping on the rod towards the pivot in such a way that it maintains the angular velocity omega naught of the rod. ये अपनी चलने की स्पीड इस तरह से सेलेक्ट करता है कि ओमेगा नॉट कांस्टेंट है, राइट? तो व्हाट वी हैव टू फाइंड? वी हैव टू फाइंड दिस डिस्प्लेसमेंट एज फंक्शन ऑफ टाइम. So if we consider free body diagram at certain position, when the rod is rotated by angle theta, there is weight acting on this. There will be some internal forces like normal action or friction, but that will be internal. If we consider our rod plus insect as a system, then we may think that we apply torque equal to I alpha relation, but we will end up in a mistake. Why? Because here omega is constant, so alpha angular acceleration will be 0, but there is torque. This weight is going to get some torque about this pivot, so we will find a contradictory relation, right? This will not be satisfied. Here we have non-zero value, here we have 0. Basically that mistake we are committing, because this relation is not applicable here, because it is applicable only if I is constant, and that too about pivot or Cm. So it is, we have a pivoted point, so that way it is correct to apply, but the condition that I is should be constant here is not being satisfied, because insect is moving towards this pivot, so I of this system is changing. So which relation we should apply? Torque equal to dl by dt. This is the basic relation, like force is equal to ma only if mass is constant, but if mass is variable, then this is the general formula, F equal to d by dt of momentum. Similarly, we should apply this relation. So at any angular position theta, we can relate theta in time, because omega is constant, that is omega naught to theta. Theta can be written as omega naught t. And in this position, what will be torque about this pivot? If total length is L, it has slipped by distance x, then obviously this torque will be mg into arm length. इस पर जो यहाँ से perpendicular डालेंगे, that will be this length sin theta, L minus x sin theta. Theta is omega naught t. I have put in here minus sign because angular momentum is anti-clockwise due to this nature of omega, and this torque is clockwise. So I have taken angular momentum as positive, then torque will be negative. And let us do expression of angular momentum, what it should be. So there are two kind of velocities. One is toward this pivot, another is due to rotation, that will be omega into L minus x. This insect have two kind of velocity. This velocity v which passes through the pivot will not create any angular momentum, because as per definition we drop perpendicular on the velocity vector from that pivot, from that point about which we have to find angular momentum. तो ये एंगुलर मोमेंटम में कंट्रीब्यूट नहीं करेगा, तो ये वाली जो वेलोसिटी इसकी ओमेगा एल माइनस एक्स, इसे मास मल्टीप्लाई कर दें, मोमेंटम हो गया, एंड दिस मोमेंटम पर यहाँ से परपेंडिकुलर फिर लेके मल्टीप्लाई करें तो ये हो जाएगा एम ओमेगा एल माइनस एक्स का स्क्वायर, और इन सिंपल वर्ड्स वी कैन से आई ओमेगा इज हियर करेक्ट बिकॉज only due to rotation we will get angular momentum, so I omega will lead to a correct expression. We can directly write I omega, and this velocity will not contribute in angular momentum. We can realize it as I explained. Now find dl by dt. Dl by dt can be written like this. This is not difficult to realize. So now equate this relation dl by dt equal to torque from here, dl by dt, and from here torque. If we substitute these values, we will finally land up this equation, and it is easily integrable. And we apply here boundary condition, initial condition, that at t equal to 0, x is 0 because insect was here. We get c as 1 by omega naught. So finally equation will be this one. This is the position time relation, this position. And another question here can be asked, find the omega naught in terms of g and l if insect reaches at pivot at the same time when rod is rotated by 90 degrees. Similar question was asked in IT years back. So we can place here x as small l and omega naught t as pi by 2. So we will get a relation between omega naught l and g, right? ये IT JEE 92 में आई हुई प्रॉब्लम है. दिस इज बेस्ड ऑन सेम कॉन्सेप्ट कि जहाँ टॉर्क इक्वल टू आई अल्फा नहीं लगाया जा सकता, बिकॉज यहाँ भी आई विल बी चेंजिंग विद टाइम. तो वी विल अप्लाई टॉर्क इक्वल टू dl by dt, रेट ऑफ चेंज ऑफ एंगुलर मोमेंटम, राइट.